So on number 11, the first thing we're going to focus on is this. And that's the biggest challenge, I would say, of the whole problem. Once we find that answer, we'll just take cosine of that answer. So we're just going to focus on this section, and we're going to say the cosine of some angle equals a half. Now, inverse cosine is which two quadrants? Right, first and second, something between 0 and pi. Since this particular cosine is a positive, is it going to be the first quadrant or the second quadrant? First. All students, so here's where it's positive, here's where it's negative. So it's going to be a first quadrant answer. Now you just need to know your table of values. What angle is it that has a cosine of a half? Pi over 3. Okay? If you need to, put the chart at the top of your paper. I'll put the chart up here on the board. And again, I'll do the question of put your 0, 30, chart on your paper the second you get your test on this. So you can always just reference it and not, because if you get caught up like thinking about that every time, it's going to detract you, as it just did, from where were we in this whole process again, because that's when it gets really confusing. That's why in Algebra 2 we make you memorize these, because there's so much logic that goes into this. If you have to take a time out mentally to think about that, you've just totally have to now start at square one. You lose your train of thought. So going back, the angle, and we're looking for the quadrant 1 version, the reference angle is cosine equals 1/2 at pi over 3. Yes? And since it's the first quadrant, we're just going to say it's pi over 3. So this is still there, and this whole thing just became pi over 3. That equaled pi over 3. And then you just answer the question, what is the cosine of pi over 3? Go back to your chart, use it forward, a half. Yes? Number 12, working inside out, this is actually the easier part. What is the sine of 3 pi over 2? Your chart's going to give you what the sine of its reference angle is, right? Is it, which is 1. Is it a positive 1 or a negative 1 now? Because the sine of 3 pi over 2 is, all students take calculus, 3 pi over 2 is not actually in a quadrant, it's down here. Would that be a positive 1 or a negative 1? Negative 1. Right? The way I like to think about sines is that it starts at 0 and increases to 1. And then again, if you're right on one of these poles, if that's 0, that's 0. If that's 1, then this opposite side is negative 1. Okay? What else also makes sense about that being negative 1 is that sine is positive this entire time, all students. So that entire time it's positive. And this entire time it's negative, so it only makes sense that between those two negative quadrants it would continue to be negative. If you want to think of it that way, that works too. All right, so that's -1. So now we're at inverse sine of -1. So the setup for this is that the sine of what angle equals -1. So if you look at your reference table, 1 is pi over 2. So we know whatever we choose has to have a reference of pi over 2, right? It's not exactly pi over 2 because that's +1. The only other angle that has a reference angle of pi over 2 is 3 pi over 2. That is what the sine of that is -1. So this is 3 pi over 2 is your answer. You're not going to like this. No, it's not that big of a deal. It's what we've been talking about. But inverse sines have to be in which two quadrants? Anytime you take the inverse sine of something, your final answer has to be between first and fourth, -pi over 2 and +pi over 2. We just picked 3 pi over 2, but that's not in, we need the coterminal of that. That's what is coterminal to 3 pi over 2? So what also falls there, but it's between -pi over 2 and +pi over 2? -pi over 2. So we have to take that version of that angle so that we follow whoever's rules those were on what the inverse sine has to be. Yes? Okay. Next one, inverse sine first. We're taking the inverse sine, so we have to be between -pi over 2 and +pi over 2. It's the sine of some angle equals 1/2. So it's positive. So the good news is it's in your first quadrant, which means whatever our reference angle is our answer. What's the reference angle? Pi over 6. So this whole thing is pi over 6, so we're looking for the cosecant of pi over 6. Which is the same thing as 1 over the sine of pi over 6. What is the sine of pi over 6? 1/2. What's 1 divided by 1/2? 2. We don't have to worry about the outermost operation we're doing here is cosecant. So we don't have to worry about that, which quadrants are we limited to kind of thing. We did that in the beginning. Same thing over here. We didn't have to worry about that in our final step because our final step was taking the cosine of something, which just anytime you take the cosine of anything, it's between -1 and 1. But it's when the inverse thing is on the outside that we have to think about that. Okie doke. All right. Inverse cotangent. So we're looking for the tangent. Well, do you want me to split this up into 2, or can you follow me saying that the tangent of some angle equals 1 over √3, which is √3 over 3? You see how I reciprocated all at the same time? Reciprocated and rationalized. So we don't really know inverse cotangents. We know inverse tangents. So the tangent of some angle has to equal 1 over √3, which is √3 over 3. And inverse tangents are also limited to the first and fourth quadrants. The good news is this one's positive anyway, so it's going to be a quadrant 1 angle, which means your reference angle is the answer. So what is the reference angle? When is the tangent equal to √3 over 3? Pi over 6. So this just ends up being the tangent of pi over 6, which is √3 over 3. Any questions on that? All right. Do the next one on your own, and let's see what comes up. Questions that come up. Yeah. Okay, hold on. So you probably did the sine of pi over 4. Got, just from your chart, root 2 over 2, right? So the inverse tangent of root 2 over 2. And then you're trying to figure out the tangent of what angle equals root 2 over 2. You look at your chart, nothing's on there. You have no choice but to do this with your calculator. Now we're talking. Well, the problem is, and I haven't had you touch your calculators yet, is because if there is an exact answer, like negative pi over 2 or root 3 over 3, if there is an exact answer option, that's what you need to have. Okay? And your calculator is going to give you the decimal version, and that's going to be very difficult. Fine. Unless it was 0.5, you could know that that's a half, but these two would be very difficult. So, for this one, you just really need to type in inverse tangent. Now, this one started in radians, and the rule with trig is if it starts in radians, you need to give the answer in radians. So, first things first, make sure your mode is in radians, and then you really just have to type in the inverse tangent of root 2 over 2. So second tan will give you inverse tangent, and then root 2. Make sure you close your parenthesis, your first parenthesis after the root 2 over 2. You also have to know how to use that, which is 0.6154. Well, we'll do 61, so let's say it around. It says exact value of. Well, we'll do, just do 0.615. It's impossible to do an exact value for this one, unfortunately. I wonder if this is a mistake or if that was the, what's that? During that one. Well, if it doesn't, if your chart thing doesn't, that maze doesn't come out in your chart, you know it has to be a calculator one. Let me just make sure this one. This is going to, so let's see what happens here. Tangent of pi over 3 is what? Radical 3. So we're just changing this to inverse cosine of radical 3. So we're trying to figure out the cosine of what angle equals root 3. Look at your chart, look at your cosine column. Which angle equals root 3 is not there, right? So on your calculator, yeah, I know, there's a reason, and we'll talk about it. This is a conversation. If we do inverse cosine of root 3, we're going to get an error. Anybody know why? For 3 bonus points. I'll give you a hint or something to think about. Radical 3 is the same as 1.7. So why is
So
Okay, who thinks they're potentially going to get bonus points by giving me a serious answer? And you would write, by the way, your calculator gave you undefined on this one. You would write undefined. The error is the same as undefined, so you would do that so that you don't need to be confused about it. You know, I would like you to understand why that happened, which I'm going to tell you now. But as far as getting the problem right on a test, if it says undefined, you write undefined. Andrew. Right. Anytime you take the cosine or the sine of a number, it has to be between -1 and 1, technically. So the cosine, if you look at your chart, and same is true for sine. Sine starts at 0, it increases to 1. All of those numbers in between are between 0 and 1. So the same is true for cosine. You'll remember that if I show you what the graph of sine looks like. It just keeps going back and forth between 1 and -1. So any angle that you take the cosine or the sine of, at maximum is 1 and is at minimum -1. So if you're trying to figure out, well, cosine of what angle would give you 1.7, not going to happen. Because your cosine graph, which we do get into later this chapter, yep, your cosine graph does that. Starts at a maximum of 1 and goes down to -1. So where does this cosine curve ever equal 1.7, which would be up here? Never. So unless you shifted it up or down or something, or an amplitude change. But the fact of the matter, so just to fix a little bit what Andrew said, he said it's out of the domain essentially. It's actually out of the range of cosine. You can only have a cosine answer that's between -1 and 1. So, you know, as we get through the graphing, and I remind you of that, hopefully that makes a little more sense. But if your calculator gives you an error, then the answer is undefined. Okie doke? No, Andrew does. Thanks for saying that. So I can remember. What would you do if you got 10 extra bonus points?
I'd cry.
And you could give them away to anybody. That should be my new spiral question. What would Connor do? Connor, tell us tomorrow what you would do with your 10 bonus points. Brock, you can do that too. Oh yeah. Andrew, I can confirm Andrew does not need them because Andrew did exceptionally well on his Sudoku bonus.
Wait.
Okay, I think with the Sudoku, it should be like you get show me more.
Oh, like a completed puzzle. Well, you will just by the nature of getting more per square. Like a 2-point extra bonus for a completion. All right, I'll think about it. All right. Okay, 17 and 18. I think you're going to notice right away that they're a little bit different. So inverse tangent of 5/12, so you're looking for the tangent of what angle equals 5/12. And we do want an exact answer for this one, which you're probably not going to be able to come up with on the calculator. Let's pretend I did it on the calculator. So inverse tangent of 5/12. 5/12 is clearly not on our chart. Oh, Ellie, I don't think you want to miss this. Just give me like 2 minutes. Inverse tangent of 5/12 is clearly not on our chart. So let's say we used our calculator. Inverse tangent, 5/12. We got that crazy number. So we would be looking for the cosine of that crazy number, which we can then just type in. Cosine of, don't round that number, go up and grab it verbatim. You didn't? Okay. You've never done that? Yeah, I'm not a storer. I never store anything, but I know that, at least that the Hills store a lot. I almost never do. So, if I have this crazy decimal and I now want to take the cosine of that number, I hit cosine, I can just scroll up to whatever number I want to grab and it will pull it down. Yeah, you just scroll up to it, highlight it, hit enter, and it will bring it down. Or a second answer, but sometimes you need to go back and grab. Right. I have. Okay. Back to this problem, because this answer is not exact. This one is one that your calculator will give you that decimal. No, undefined would have come up as an error. Here's the idea here. Draw a triangle. Yep. Okay. We're going to go back here because we don't know the tangent angle, but we can set up with any triangle, any right triangle, and I'll just draw a random one. I'm going to call this theta. And if the tangent of that angle is 5 over 12, which side is 5 and which side is 12? Correct, because opposite over adjacent for tangent. So I would label the opposite 5 and the adjacent 12. And then how do I find the third side? Because at the end of the day here, they're asking me to find the cosine of the angle. Right, the cosine of the angle, which is what they're asking me for, is adjacent over hypotenuse, which is going to be 12 over something. I don't have the hypotenuse yet, but the Pythagorean theorem will give me that it's 13. No, if you know your Pythagorean triples, you should just know 13. If you don't, 5 squared plus 12 squared equals x squared, you have an extra step. But hopefully you're familiar with 3, 4, 5s, 5, 12, 13s. So cosine is adjacent over hypotenuse, so your answer is 12 13ths, which, for the record, that's what that decimal was. Okay, instead of going through that, what would you do? Alpha. Y equals. Math. Frac. You're right, it would. Okay, last one here. The sine of some angle, and I'm just so you process that again, the sine of some angle equals a half. And actually, this one we can use our chart. Because inverse sine has to be between quadrants 1 and 2, or 1 and 4 rather. Because sine is positive, it's quadrant 1 or 4. 1. The reference angle is pi over 6, and since it's quadrant 1, we're going to keep pi over 6. So now we need the secant of pi over 6, which is 1 over the cosine of pi over 6. And what is the cosine of pi over 6? Radical 3 over 2. And when you do 1 over a fraction, it essentially flips the fraction to 2 over root 3, which will rationalize to 2 root 3 over 3. That's something the calculator is not going to do for you. Again, when the chart is usable, the calculator is not going to cut it. Got it? So I made a mistake and collected